in this challenge review, we're going to create the flip behavior. The most important part of knowing how to do this is that we can visually see this behavior. I need to get a handle onto the sprite renderer, and I need to say, hey, when move is greater than 0, the flip x is false, and when move is less than 0, I need to say flip x is true. To do this and make it very clean and organized, I can basically just fill in my pseudocode here. So here, I'm going to say if, we're going to say if move. So if move is greater than 0, then what do we need to do? We need to face right. So we need access to that sprite renderer component. So to get that, we're going to create a new variable, private sprite renderer, and we're going to call it underscore sprite. And from here, what we're going to do is we're going to say if move is greater than 0, we're going to go ahead and say underscore sprite dot flipx, and flipx needs to equal false if it's greater than 0, right? Because if it's greater than 0, we're going to the right. And if we're going to the right, flipx, you can see here, is false. If we're going to the left, it's less than 0, and flipx is going to be true, which will turn us left. So now that we have that logic there, we can then go into our else if, and we can simply say here, else if move is less than 0, then we're going to say underscore sprite dot flipx is equal to true. And that is all we should have to do. If we save this, we can go ahead and test it out. All right, so we run right. And right now we're getting an object reference not set to an instance of an object. That means we're trying to access a component that is null. So to fix that, what we need to do is actually assign the handle. I created the sprite handle, but I never got the reference. So in void start, I need to say underscore sprite equals get component in children, and I want that sprite renderer component. I'm also going to rename this to player sprite just in case we get into more sprites down the road, just so we have clarification of what we're working with. So here, private sprite renderer, and then here we're going to say player sprite, and we're also going to rename the animation as well. So we'll call this player anim. Okay. So all we have to do now is quickly fix these. You can right click them, quick actions and refactoring, and you'll see here that it should find what it's looking for, although it's not. So we're actually just going to rename this real quickly to player anim, and this one here to player sprite. Okay, with those variable changes, we can now come down here. You can grab player sprite. We're going to do player sprite.flipx and player sprite.flipx. Okay, let's go ahead and save this and see if it works. Make sure you stop Unity. And it looks like we have an error here, so we need to change this to underscore player anim. And we'll save this. Let Unity compile. All right, let's go ahead and run this, and we should have a nice functioning flip. So if I run to the right, here we go. If I run to the left, we flip. Perfect. It's exactly what we want. One of the things, if we want to take this a step further, is we can organize it into its own flip method. So here, let's erase our pseudocode, and let's go ahead and create a flip function that we're going to call basically passing in this info. So here, we can basically create a new method down here, and we'll call that void flip. And what we're going to do here is we're going to pass in a float because I need to know what our move value is. So here we're going to say float move, and simply just copy the logic. Take it, and there you go. If move is greater than 0, do all this, and so forth. Now all we have to actually do here is just call flip. So another thing you can also do to even clean it up even further is you can actually create a bool for facing right. And this might actually be even cleaner. One thing we can do that way, we can keep the logic visual here. So I'm actually going to undo this. We can say if move is greater than 0, let's just call flip. And then here, else if move is less than 0, we're going to call flip. And then what we can do is we can come down here and you can say inside this flip, we'll change this bool to a facing right. We'll say bool face right. And so if move is greater than 0, we're going to say flip, and you'll see here that we're going to put in, is it facing right? If it's greater than 0, then yes. So we're going to say face right is going to be true. And then here, if move is left, well, flip equals face right is false. So here, what we're going to do now is we're going to check for facing right. So here, if face right is equal to true, then the flip x needs to be 0. So, or null, or false. So we're going to say sprite renderer, player sprite dot flip x equals false. So if facing right equals true, player sprite dot flip x equals false. And you can just simply add an else here, or an else if you wanted to. Else if facing right equals false, that means that you're facing left. We need to say player sprite dot flip x equals true. Let's go ahead and save this. We're calling that function right here in update. And this is just to demonstrate that there are multiple ways to solve one problem, guys. There is no right or wrong. There are some ways that are better performance-wise and cleanliness-wise, but for the most part, there are just several ways to solve a problem. So as long as you get a functioning result, that's what's important. And here you go. We are flipping. All right. So I'm happy with that result, and I'll see you guys in the next video.